types of solutions. And you might be wondering, what does that mean, like types of solutions? Well, it means one of these three things. A solution is when the equation is true, but sometimes it could be always true, never true, or just true one time. So I'm going to take this equation and I'm going to type it into math.new. So I go to math.new, start a new whiteboard for myself. I have 2x plus 6, 2x plus 6 equals, and then on the other side I have 2 times the group 3 plus x, 2 parentheses 3 plus x. So I have this first equation to start with, but let's see what happens as we start to move things around. So I'm going to multiply the 2 inside the parentheses by dragging it in there. After I've dragged it, I kind of notice something. I notice that it's the same thing on both sides. In other words, I have 2x plus 6 equals 2x plus 6. Well, if I were to if I were to, let's say, try to get rid of that 2x, so if I add a negative 2x to both sides, that's going to make just 6 equals 6. I could even go further if I wanted to subtract the 6 from both sides, and then I'd have 0 equals 0. Whether I stop at the very end or I stop part way down, it's noticing that I have the exact same thing on both sides, which means that this equation will be true forever no matter what I plug in for x. Another example of that, like where it says 2x plus 6 equals 2x plus 6. Let's say I plugged in some random number, like 2 times 7. 2 times 7 plus 6 is going to still be 2 times 7 plus 6. No matter what I plug it in on one side, it's going to be the same on the other. So this is always true. Let's screenshot this work here, capture it, and we'll paste it into this area with the notes. I don't need the original one anymore. I can make this a little bit smaller. But it is always true. And if it is always true, then that's going to match up with something called infinite solutions. All right, let's see what happens on the next one. It's 2x plus 3 equals 2 times the quantity 3 plus x. It's actually very similar to the first one, so I'm going to click on the little circle next to it, go back to that line, but I'm going to do fix a mistake. That allows me to edit something very small. So now I have 2x plus 3 equals 2 times 3 plus x. Well, this one, when I work it out, I don't have the same thing on both sides. So let's see what happens after we start doing a few things to them. So let's try to get rid of the minus 2x. I'm going to do minus 2x on each side. That gives me a 0 on the right. And if I move these two x's next to each other so they can combine, I get a 0 on the left. And I wind up having 3 equals 6. 3 does not equal 6. In fact, 3 will never equal 6. So I'm going to say that that's never true. I'll delete this one, replace it with my work. And if it's never true, then that means it is no solution. Sometimes they'll come up with an equation and there is no solution that makes that true because it started off with a bad example. Now this last one is probably going to be our most common one, the majority of the equations that you see. So again, I'll go back to the beginning, and it says 2x minus 2 is equal to 3 minus x, I believe. Let me double check. Yeah. So now when we distribute this 2 on the inside, we have 6 minus 2x. Well, I could add 2x to both sides. I'll click on the equal sign, add 2x. That makes a 0 for the x's on the right, but I can combine these two positive 2x's on the left to make 4x. Then I can add 2 to both sides to make a 0 on the left and make an 8 on the right. And lastly, we'll divide by 4. And that gives me x equals 8 over 4, or you could say x equals 2. So when it says x equals a number, that's only true for one number, and it's only true for the number 2. In other words, if I were to substitute a 2 into the left side for x, then I have 2 equals 2. But if I choose any other number, like 5, I can't put a 5 in for x because 5 does not equal 2. So this is only true for one time, and that one time is that one solution. All right, now on these bottom ones, what we're looking at is trying to identify the error and then go back and redo the problem correctly. So we're going to do more solving equations with math.new. So when I look at this, I'm trying to see what's going on. It might be easier for me if I go ahead and type it into math.new and see what happens differently. So I'll type in 2 times x minus 4 as a group minus 5 equals 13. To get a clean, fresh screen here, I'm going to just reload. And so I have 2 times a group here that's x minus 4, and then minus 5, and altogether that equals 13. All right, so again, let's multiply this 2 with the distributive property. I don't have to do that first. I could have moved the 5 over, but I'm going to try to follow the steps that they did. And now I notice that I have 2 constants with no variables next to them, so I can combine those. And I get 2x minus 13 equals 13. Now I'm going to add 13 to both sides to make that minus 13 on the left a 0. I got 2x equals 26. Then I can divide by 2 and get x equals 13. Now let's compare that to what we had before. For me, I can take these items and I can move them side by side. On a Chromebook, you just simply drag it over to the side and it will snap over to that side of the screen. My computer right now is not a Chromebook, so it's not the same move for me, but that's just fine. Okay, so I notice that I have 2 times x minus 4 minus 5, and they still have 2x minus 4 minus 5, but I have 2x minus 8. So that means that my error, I'll grab an arrow here for the error, is right there, and I'll color it red. So that's the first error, and if I want to get even more specific, I can say it's right here at the negative 4. They didn't distribute or multiply that 2 to both sides. Let's zoom out a little bit so I can save that. Zoom back in, get the full screen. Awesome. So that's where the error was, and now I have work that I can screenshot and put in there that shows the correct answer, the correct work. I'm going to go ahead and end the video there just to kind of leave it as an example. If you finish the last 2, that's great. It's good practice, but at least we have a demonstration of how to do all the things.